Hi students, so now we will be solving this particular problem. This problem looks a bit complicated, but it is very easy. It just comprises a few trigonometric manipulations which will ultimately solve the problem. So first what we have to do here is break into the respective formula. Now we haven't yet come out to that particular formula in our trigonometry section module. So you will have to remember one thing, that what is the formula of sine a plus b. Okay, so first what we will have to do is sine cube x sine x plus alpha. What I'm trying to do now is basically I'm trying to manipulate the denominator a little bit, okay, for the simplification of the respective problem. So first what we have to do here, that in place of sine cube x sine x plus alpha, we have this sine a plus b. Okay, so how will I break this form? Sine a plus b is nothing but sine a cos b plus cos a sine b. All right, so this is the particular formula for sine a plus b, which is nothing but sine x cos alpha plus cos x sine alpha. Okay, and sine cube x will remain as it is. Now what will I have to do is multiply the numerator and denominator by a sine. Like what we have to do here is I have to take a sine x common. Okay, I will take a sine x common. So inside what will I be left with? Cos alpha. And here what will I be left with? Now as you can see that there is no sine x here, so I have to forcefully induce sine x here, alright, because I have taken sine x common, right? So how will I take sine x common from a term which does not even have sine x inside of it? So in that case I have to forcefully induce sine x in the term so that I shall be able to do that. So what will I do here is I will divide by sine x, multiply by sine x, and I have a sine alpha here already. So what supposedly happens here is that as I divide and multiply by sine x, ultimately I get this form only, right? Cos x sine alpha. But I have forcefully induced a sine x here so that I can take the sine x common. Okay, now if I do this, okay, leave it here. So what I have done here is basically from here I have taken this sine x common, and from this term I have forcefully taken this sine x. Okay, and this sine x has also been taken common here. So what I'm actually left with is, all right, this is getting a bit confusing. How will I explain it to you is, let's break it more. Say I have a sine cube x here, okay? And what I am trying to do is from the two terms that I have here, I am willing to take sine x common from both of these terms. So how shall I take sine x common from a term which does not even have sine x inside of it? Now I hope you understand that the first term has sine x inside it, but the second term does not have sine x inside of it. So in order to take sine x common from both of the terms, I need the presence of sine x in both of the terms. But in the second term I don't have a sine x. So in that case I have to forcefully induce a sine x, okay, forcefully induce sine x, so that ultimately after cancelling out we get 1 only. Okay, so I can write this exact form like this. By simply multiplying by sine x and dividing by sine x, I get this term only. But here is a plus, that I get a sine x now in this term. So I have a sine x here, I have a sine x here, and I can take a sine x common. So when I take a sine x common, I am left with a cos alpha, and I can write this cos x by sine x as cot x sine alpha. Now the last thing is that here the power is 1, and as I told you, the base is the same, and both of these functions have a multiplication sign in between. So according to the rule of powers and exponents, we know that the two powers will simply get added. So I will get a sine to the power 4x cos alpha plus sine alpha cot x. Okay, so now I have this particular task of first replacing this particular part. Like, how shall I write this? We took this as a denominator, right? And then we can replace this by this, right? So I can write integration of dx divided by, now tell me, this was root over of, right? This entire thing was actually root over of, right? So in order to get the root over, finally when we do the root over of this, what do we get? We get a sine square x, alright, and inside the root over we get a cos alpha plus sine alpha cot alpha. Alright, I hope you understood it. Sine 4x is nothing but sine square x whole square, right? And when I take the root over of this, what do I get? I get a sine square x, isn't it? This square, after doing the root over, we simply get a sine square x. That is only what I have written here. And the rest part remains the same because we cannot bring them out of the root over sign. Okay, we don't have a, all right. So we don't have any respective powers with the help of which we can actually bring it out, and we also don't need to, because next we will be creating some form of manipulation here. And what's the manipulation? First is I will make this sine square x go in the upward part, that is in the numerator. So 1 by sine square x is nothing but cosec square x into dx divided by, I am left with a root over of cos alpha plus sine alpha cot x. Now listen to me very carefully. Now what you have to do is, in the denominator, if you consider the denominator part to be as your t, then what will you be getting as derivative? Derivative of cos of alpha will become 0, because we are taking derivative with respect to x. Okay, so this derivative will become 0. The sine alpha will act as a constant, all right, because we have alpha here and we actually want to take the derivative with respect to x. So essentially we are only left with a cot x, which is nothing but cosec square x into dx equal to dt. All right, so now what shall I do is, I can write cosec square x dx as minus 1 by sine alpha into dt. Okay, so now that we have come up till here, we will simply replace this. How shall we do that? Cosec square x dx will be replaced by 1 by sine of alpha, right? And there will be a dt here, and I have taken this part as a t, so this will be nothing but a root of t. Now as you can very well understand that sine alpha is a constant, so we will no longer keep it inside of the integration and make our integration more complicated. We will simply take it outside. So ultimately we will be left with a t to the power minus half into dt, right? As I have already told you earlier, that 1 by root over of t is nothing but 1 by t to the power half, because root t can be represented as t to the power half. And if when this thing goes up, it becomes a minus half. Okay, so many times I have told you this, so I hope there is no confusion regarding this particular part. Okay, so now that we have reached here, what next? Simply integrate. So what we will be having is t to the power minus half plus 1, which is nothing but t to the power half, divided by minus half plus 1, which is nothing but half, plus c. So we will essentially be left with 1 by sine of alpha. This 2 will actually climb in the upward direction, so we will actually be having 2 in the numerator, and in the place of t to the power half will get replaced by a cosec, t will be replaced by cos alpha, like this part, okay, cos alpha plus sine alpha cot x, cos alpha plus sine alpha cot of x plus c. Now finally what you can do is you can replace this as cosec alpha, alright, because we know that 1 by sine alpha is nothing but cosec alpha into this part was actually to the power half, alright. So we will get a root over of cos alpha plus sine alpha cot x plus c. This problem is actually very easy, okay, but as I said that there are a bit of trigonometric manipulations, like here we used sine a plus b formula, alright, and here we performed a bit of derivative, alright, and also the fact that I took a sine x common from here, okay. So what I am trying to do is basically trying to simplify the denominator first. As soon as I simplify the denominator and get this part, it's easier for us to take the derivative and then get our respective solution. This problem was a bit long, but actually it was very easy since we haven't solved such problems in abundance. So you might think that this is a very difficult problem. It is really not, and I have really explained you every single line here, okay. I have even tried to explain you those things which it's expected that you would know, just in case there is a problem. This is why I explained every single thing, alright. So if you really like my video, then please don't forget to like, share, subscribe, and don't forget to hit the notification bell icon for more of such exciting content, alright. Your support is very highly required for me to proceed ahead with this channel. So let's move ahead to the next video.